You ever wonder how we keep tabs on some of the planet's most powerful, most unpredictable forces? Yeah, I'm talking about active volcanoes. We're going to explore how we watch them, not from the ground, but from hundreds of miles up in space. Let's get into it. All right, look at this number, 500 million. Just let it sink in for a second. It's a massive, almost hard-to-imagine figure. And no, it's not a budget or a stock price. It's a number that represents a profound global risk. That's right, 500 million people live their daily lives right in the shadow of a potentially active volcano. So, you see, this isn't just some abstract geological fact. We're talking about global safety. And it's exactly why keeping a close watch on these fiery giants is so absolutely critical.
So, that's the big question, isn't it? How in the world do we get the timely, crucial data we need to understand and maybe even predict what they're going to do next? Well, the answer? It's orbiting high above our heads.
Okay, so first things first, let's just wrap our heads around the sheer scale of what we're dealing with here. We are not just talking about a couple of famous mountains you see in documentaries. So get this, there are about 1,500 active volcanoes on land alone. Most of them are crammed along the Pacific Ring of Fire, which is basically the most volcanically active place on Earth. Around 500 of them have blown their top in recorded history, and on an average year, about 50 of them will erupt. The key takeaway here? This is a constant, ongoing global thing that demands our full attention. So how do we even begin to tackle this? Well, we've got some incredible tech on our side. It's time to meet the real heroes of this story, the satellites that serve as our tireless eyes in the sky. Now, two of the heavy hitters in this game are the European Copernicus program and the US-led Landsat program. You can think of them as these massive public services constantly streaming data that's just vital for scientists and disaster response teams. So how do they see? Well, different satellites have different superpowers. Take Sentinel-1. It's the all-seeing eye. This thing is wild. Its radar can literally pierce right through clouds, thick smoke, and even pitch-black night to see tiny changes on the ground, like new lava flows or cracks opening up. Then you've got what I like to call the detail-oriented twins, Sentinel-2 and Landsat-8. They're like these super high-res photographers, capturing images in all sorts of different wavelengths of light, giving us these incredibly rich, detailed pictures of what's happening on the surface. But hey, eruptions aren't just about lava flows, right? Sentinel-5P is our atmospheric specialist. It basically sniffs the air, looking for gases like sulfur dioxide. And that's huge, because it can tell us a ton about an eruption's intensity and its impact on air quality and even the weather. And Landsat-8 has another ace up its sleeve. Its thermal infrared sensor, or TIRS, can see heat. I mean, this is an absolute game changer for spotting active lava flows that might be hidden by smoke or darkness, giving first responders a crystal clear map of the danger zones. Okay, so we have all this incredible tech. But how does it let us see things that are literally invisible to our own eyes? Let's break down how this magic actually works. The key here is something called spectral bands. Now, the easiest way to think about it is like giving a satellite superhero vision. It can see colors of light that we can't, like different shades of infrared. And each one of these invisible colors can reveal something totally different and super important about what's happening on the ground. And wow, does this drive the point home. On the left, you've got Mount Etna in what we call true color. It's basically what you'd see if you were flying over it. The hot lava is dark, it's smoky, and it's really hard to pick out. But look at the right. That's a false color image. Scientists used infrared bands to make heat glow. And boom, the danger just lights up in bright red and yellow. It's impossible to miss. So how do they make these incredible images? It's actually a pretty cool and straightforward process. First, the satellite captures the data in all those different bands. Then, scientists select the specific bands they want to focus on, say the ones that show heat. Third, they assign those invisible bands to the visible colors we can see, red, green, and blue. And voila, the invisible becomes visible, revealing a hidden story about our planet. All right, so let's take this out of the theoretical and into the real world. Let's see how this all plays out when scientists are trying to decode what's happening during an actual, live eruption. Okay, check this out. This is the Kilauea eruption in Hawaii. By mixing and matching different spectral bands from the Sentinel-2 satellite, analysts can create different views for different jobs. One combination makes those lava flows absolutely pop, showing the immediate danger. But a different combo might be better for seeing how the eruption is damaging nearby forests, which is crucial for understanding the long-term impact. You know, there's a quote that just nails this perfectly. It explains it by using this technique, what would naturally be dark, hard to see lava becomes this bright, impossible to miss river of red and yellow. This single technique transforms a satellite picture from just a pretty photo into a powerful, life-saving analytical tool. Okay, but here's the part that I think is the most incredible. This technology, this superhero vision, isn't locked away in some high-tech government lab anymore. It's actually available to you, to me, to everyone. I'm talking about tools like the EO browser, which lets anyone get their hands on this imagery for free. You can play around with pre-made settings for famous volcanoes, or if you're feeling adventurous, you can even write your own little scripts to look for specific things. And for people who really want to get into the weeds, there are even guided coding tutorials. The barrier to entry has just totally vanished.
And really, this is the main point. This is huge. The ability to monitor our own planet is being put into everyone's hands. This data is for students working on school projects, it's for curious hobbyists, it's for anyone who just wants to better understand this amazing, dynamic world we all live on.
I mean, think about it. From tracking massive eruptions as they happen to spotting the tiny, subtle signs that one is about to begin, our view from orbit is completely changing our relationship with volcanoes. So it all leaves you with this one big thought, right? With these powerful new eyes on our planet, accessible to more people than ever before, what other secrets is the Earth just waiting to show us?